All right, example 8, simplify x to the 5th, y to the 0, z times p to the negative cube, z to the 0 minus 4x to the negative 5th, z to the negative 1st. All right, what I have here is a structure of a single object outside being multiplied by the first object and the second object. Okay, as of right now, we haven't learned the division rule of power, so we're going to pretend that that doesn't exist. So we're going to have to do it this way. We're going to basically apply what we just saw, that power structure problem, like when we see this type of problem. When I do the blue times this first piece here, I'm multiplying this stuff times that stuff, right? So it's just like that last problem here. So when I'm looking at this product here, this times this, x times no other x's stays the same, y times no other y's stays the same, z times z, we add the powers, 1 plus 0 is 1. There's no other p, so p to the negative third. Okay, so as I multiply it out, distributive property here, outside object times inside object, fixing what I can fix. Then, when I do the green one, again, distributive property, single object times multiple objects, the outside piece distributes through. When I'm doing this multiplication, I got a positive times a negative makes a negative. 4 times no other numbers stays 4. If this said 3 and that said 4, this would say 12. When you have numbers there, multiply the numbers as you would normally multiply numbers. I got an x times an x. 5 plus negative 5 makes 0. I've got a y times no other y, so y to the 0. I got z times z to the negative first. 1 plus negative 1 makes 0. Go ahead and get what you get, and then deal with the negative and 0 powers next. All right, so get the answer, and then fix everything. So, looking at the red term, what's wrong with the red term? There's two things. Negative power and a 0 power. Okay? Notice, x to the 5th and z are behaving themselves. They get to stay right where they're at. I probably wouldn't put the 1 on the z. I would probably just put z instead of z to the first. Y to the 0 equals 1, which is being multiplied by other stuff, so it can just be crossed off. Again, if it's all by itself, there's nothing else there except for y to the 0. 1 matters because 1 minus something matters, right? But since there's other stuff there, I can just throw that out. P to the negative third is currently in the numerator because there's no fraction look to it, so it belongs in the denominator. So you put it where it belongs. So the first term's fixed. All right, the negative power becomes a positive power by putting it where it belongs. The 0 power goes away. The positive power stays right where they're at. The green term, 4 is behaving itself. Sometimes people see a minus in front of the 4. They got this idea of negative powers. I'm supposed to move things. This is 4 to the first power. The power is positive. The number is negative. All right, so negative 4 is right where it belongs. 0 power is 1. 0 power is 1. 0 power is 1. So minus 4. Okay. Let me show you one thing I've seen people do. I'm going to do it in a different color so we know it's not right. That's the right answer. I've seen people do this in a problem like that. Let's make that fraction bar go all the way across. Let's just make the whole thing a fraction. Because I feel like it. I think it's awesome to do that. Okay. 4 is not in a fraction. This is a fraction. They're different terms. They're separated by a minus sign. So get a term separated by the minus sign. The fraction does not extend beyond that plus or minus sign. In order to get this to be a fraction, you need to get a common denominator of p cubed to deal with that. So don't be that person that extends that fraction mark because you think it's supposed to look that way. That's what it's supposed to look like. This is the final answer.